So when you look at, you remember your sheet, the D1
Yes.
sheet.
Yes.
That D1 sheet will be one of those that you have recorded.
Okay.
The sheet you're about to do. Then you give them names. So we are dealing with sheet 1.
Okay.
What is the data in the sheet?
Okay, so Doc, the D1 had, I think, the efficiency
I don't
for
mean the
VRS.
details. I don't mean the details. So the data are efficiency scores.
Yes.
They are not input and output variables. They are efficiency scores. For this very one, this is a data. So when you look down here, you can see that these are the efficiency scores.
Okay.
But you can see that there's a column here for OT, which is referring to the group that you are dealing with. So in this case, your MEA and then your DEA.
Okay.
So maybe your DEA comes first and goes down to the end, and then the MEA will follow.
Okay.
The key point I want to draw on is that it should follow it. It shouldn't be like DEA is on one column, MEA is on one column.
One column. Okay.
Then you rename the group A as Datos 1.
Okay.
It's coming from the data called D1. So
Yes.
from 1 to 30, in this very example, that is the name of the first group. And then the other one will continue from there.
Yeah. So in my case, I'm going to have, if I name it D1, it's going to be D1 1 to 504, and then the next one will be D1 505 to, I think, 1008.
Good, exactly.
Okay.
Now, once that is done, and in this case, I need to be sure of this one. I need to be sure why you brought to this dollar. Because else you might be confused there.
Yeah. And also there are 3 efficiency scores there. So which one is it picking?
Yeah. That's it. It's actually picking the first one.
Okay.
What I don't understand is why because look at the first one here. 0.7921, right?
Yes.
That's different. Because it's picking it from previous ones. That. So that's the whole of the D1. The D1 from 1 to 30. What is this one? So that's the same thing. No?
The 1 to 30 is for the IOC.
Yeah, so he's taking the first column. Watch it. This is the D1. I mean the data's one.
Yes.
That's the same thing here.
Okay. But what was making it take the first column? So in the case where we want it to take the second column, what needs to be changed?
Say that again.
Like in the case where we want it to take the second column.
Oh, you just, if you want to take the second column,
like the BEFF.
to be honest, ideally it should have been EFF. I can redefine that for you to see. It should have been, let me call it something like da plus 18 is equal to, I would have done it, this is where knowledge is. I would have done it taking this EFFR let me try it again. Dollar D1 like this. But he left column 1, so he would have brought the comma in front if he was using. Look at the second one.
Okay.
No, but wait. If I was to it's rather the opposite. Yeah, it's rather the opposite. So let me go back here. Let me see this. Normally, when we are setting up the input and output, how do you normally do it? I forgot to put.
It's rather wouldn't it be the D1, then before the dollar sign comes?
Yeah, is it the name of the data first?
Yes.
Double check. So it's something like this. So TBC bind bracket D1 dollar close brackets. Dollar year from one state. So this is how I would have written it.
Doc, no, the EFF VRS comes after the dollar. So it's D1 dollar EFF VRS.
No, this is the correct one. Let me show you.
Okay. Yes.
So that's how it would have been. If I was specifying it, that's how I would have specified it. So if I should show first of all, let's show D1. Okay. Second of all, let's show datas 2, datas 1. Is that not it?
Yes, Doc.
Third of all, so I'm saying that my data's 18. That's how it would have been.
Okay.
Which is the same as his data's 1.
Okay.
Just that he didn't bring the C bind. So what I'm saying is that in your case, if because this one doesn't really make sense, to be honest with you. It doesn't really make sense. It comes from somewhere.
Yeah.
So what you can then do is that you can just use this datas 18 for it. Let me put it on your WhatsApp just in this.
Okay.
So we come here. So once you've created this for these two, so the columns have been defined, like which one is for DE and which one is for MEA, you've defined them.
Yes.
Then the reason why we use this datas 1 and 2 is because we got some code from somewhere and the codes were in Spanish, and so we didn't want to change things. So we just have to rename our own into that language so that it will be easier. Now, this next thing will be to create I think I'm using a different command for this thing. Here's actual command. I think that the actual command is here, so I want to just double check. You see. You see the actual name here. So when you look at this D1 now, there's a command. There's actual name. So look at D1 here. There's a D1, right?
Yes.
And then this is a bit of the description of the data according to the column. So this one will give you a bit of an the groupings, the descriptive statistics.
Okay. No, I'm seeing the Excel sheet.
Oh, okay, hold on. You say it takes how long? How many seconds? Still not sure.
Doc, no, I'm not seeing the R.
When it comes, you let me know so that.
Okay.
All right. So
We are on the
yes.
statistical test of differences.
So I'm saying that you can look at the descriptive statistics.
Okay.
Remember, I told you that in the paper, we showed the mean as well as the standard deviation.
Yes.
Open that paper of yours for your computer. You see that when you look at that one on your own.
Okay, Doc, I've opened it.
You'll notice that the sample size is 246 for the IOC, 232 for the NOC. And the mean is 0.73. Now, when you come here in the R, you see that for this variable returns, the mean is truly 0.73.
Okay.
And the sample size is there as it was in the paper. Doesn't match what you see on your paper.
Okay. Doc, we are looking at the summary statistics.
Yes. For the variable returns, the bias corrected variable returns, the BEFFF, whatever. That's what was shown in the paper, the one I've highlighted.
Okay, Doc, I'm at R. Your screen right now is showing the R.
Yes, but you look at your paper. The paper, you have the PDF open.
Yes, Doc.
So look at the PDF and look at the IOC, look at the mean, look at the median. Or you don't see the mean in the PDF.
Okay, Doc, I don't know if I'm having the wrong paper. I'm looking at the, let me read the title. The
title is multinational operations. That's the title.
Yes. Okay, Doc. So if I go to the table 1, that's showing
not table 1. We are not looking at table 1 here.
Okay.
We are looking at statistical testing. So it is table 4 we are dealing with.
Okay. Okay, so 2, 4, 6, yes, and then 0.7. Yes, Doc, I'm seeing the same scores.
So this is what was calculated that was brought in there. I'm showing you the steps of picking things from raw to real. Because if you don't know what is happening, a command is created, a table is generated, but then not everything in the table was taken to the final paper. You got to follow the steps so that you know exactly what is being done. That will help you to just repeat that.
Okay.
So that was a described by symbol that was used.
Okay.
The next one was to calculate the Wilcoxon rank sum.
So
but you do not need to calculate the Wilcoxon rank sum.
Okay.
We have to calculate the Wilcoxon signed rank. So how is this thing going to change? Now, if you run the Wilcoxon signed rank for this efficiency score, this is what you're going to do. This is what you get. You get a W, which is 39,356. Okay. Now, when you go and check, there is some academic induction going on. That I should have done. Just a second.
Okay.
All right. Okay, so you can see, sir, the Wilcoxon test statistic here is 39,356. But the one in your way is what? It's 37,158.
That is 38, sorry, 37,000, yes, 158.
Let your eye be only there, nothing else. So that you don't get confused. This is a small corner of the book I'm looking at. Now, that shows a discrepancy between the two. So what was the cause? And I believe that the cause is that we should have looked at the bias corrected score. You see, in this work, there is an efficiency score, and there is also the bias corrected efficiency score. So I'm going to just look for the bias corrected efficiency, this one here.
Okay.
I don't know whether you see it in Maya, but this one is for B1. So let me run that. And tell me what you see in my R here. For the W, which I have highlighted.
Okay, look, 37,158.
So you can see that is exactly what was in the document.
Yes.
Okay. The next thing, so that is a Wilcoxon test, and that is what you see there. And he has, in the work, we have indicated that it is significant.
Yes.
And you remember that there was the mean, there was a
the mean and median.
The mean and median, that was shown there. Of
Yes.
course, it's the same data, so that will be in the descriptive statistics that we've already told you.
Okay.
Now, the next thing is a t-test. So I was saying that what if it is Wilcoxon signed rank test?
Okay.
And not rank. Now, this is how I would have done it. I just want to double check to see. If I was doing Wilcoxon signed rank test, I would have written Wilcoxon.test, blah, blah, blah. Then I would have brought comma. Then brought paired. Let me see whether if I start typing paired. Okay. Or pair. Is it pair true? Combines two vectors and blah. No. Okay, so normally when I'm not too sure, just go and type into Google Scholar. I've just forgotten the command. I think it's paired true, but I just want to double check. So you type Wilcoxon signed rank in R. In R. So this is a So do you see the command down here? This is a word online.
No, Doc, I'm still seeing the R Studio.
Anyway, so the command is you just make it paired true.
Paired true, okay.
I don't know why it wasn't showing, but let me go back and do paired equal to true. So let me run that. Okay. Samana.
That's fine.
I'm on my R.
I'm now seeing the Google page.
And the arrow come.
Okay.
Take some time.
Okay, I'm now at the R. Is it because the data set cannot be used for this?
No. There's no problem with it. The only thing is that this one, before you can use it, you must not have the variable organized in that order.
Okay.
It must rather be organized. You see, this data is not paired. What you say? If you can remember, they are all not 250, 250, or 246, 246.
Yes.
So that's why it is saying that your data is not paired.
Okay.
And so because the data is not paired, it makes it difficult for it. Let me type it, Wilcoxon signed rank. Do you understand what I mean?
Yes, Doc.
What do you understand?
Okay, so for us to use this one, the data has to be balanced.
So I'm just giving you the command so that when you are doing it now, on Doc is not working. So I just want you to know that in this case, it's not working because we are not having a balanced data. You get that? So you can do that later on. If the data was paired, I would have been easier. The next thing is to do the Lee test. Now, if you check your...
Look, the explanation after it.
What explanation?
No, the Wilcoxon sign rank test. That's for the first one.
The Wilcoxon sign rank test. That's what I have paired written for it.
Okay. Look, then the difference between this and the first one.
Say that again.
No, like we're having the same definition for both of them. Okay, there's the rank sum. Okay, okay.
Hey, Emily, come do Anna. Kona ko didi bre.
That is okay. Okay.
All right. So that is it. Then the next thing, check the Lee test now. Check the Lee test, and then check the test statistic for the Lee test and let me know.
Okay.
By the way, when it was rank sum, the p-value is here. So the reason why we wrote 3%, we wrote 3 star,
yes.
3 different star for 0.1% is because look at the p-value.
Okay.
It was almost 0.0000. If you check the document, we wrote the same thing, 0.000.
Yes.
You got it?
Yes, Doc.
Okay. I'm just showing you what was all shown.
Doc, what about the t-test? The 6.29.
But the t-test, we showed it here. This is a t-test in the p-value.
Doc, the one you highlighted.
Yeah. Check it against the document.
No, that's the Wilcoxon text, the 37, yeah, 37,001.
Check the t-test in the PDF.
Okay, the t-test in the PDF was 6.29.
And what do we have here?
Okay, Doc is now showing. Yeah, 6.289.
Yeah.
Okay.
And you can see the p-value.
Yes.
And you can see that here too, the good thing is that it gives you the mean.
Okay.
Check that mean against the one in the PDF.
Okay, so
you'll notice that it's the same thing.
Yes.
0.73, 0.61.
Yeah.
It's the same thing.
7324. Okay.
Now, when you are doing the Wilcoxon, it doesn't give you the mean, but this one gives you the mean.
The mean.
So
Okay.
just so you know. Now, the next thing is to calculate the Lee test. So we run for the private and then we'll run for the state.
Okay.
That one takes some long time because it goes through a lot of distributional analysis. So after we've written this one, we rename the IOC as DATOS1. And then the NOC as DATOS2. Then we now take the guy's work along the line.
Okay.
So this command will create the density function for the file. That's it. And next, we'll do some critical drawings and some things. I'm just going to highlight them, but in the process, talk about them.
Okay.
You know, it does some manipulations. A lot of you have to select bandwidth, the sequencing, bootstrapping, sampling, resampling, all of that. That's for the first data, the IOC. Then for the second data, you did the same thing, resampling, IOC. Then you get some orders for density graphs. Okay. And then, let me just run this first. You can see that the density graphs are showing here. It will show very soon. And when you check the document, you will see those density graphs. So look into the document and tell me which, yeah, but confirm it, which density graph you have in the document.
Okay, so the legend is saying we have the technical efficiency and then the scale efficiency. For
which of the density graphs there do you see it here?
Okay, Doc, I'm not seeing any of the graphs yet.
You mean my graph I've drawn?
Yes. Okay. I'm seeing the PDF.
Yeah, when my R results come, you will see the graphs.
Okay.
The PDFs, we added some colors.
Yes.
Anyway, so let me carry on with the graph. So after this, we do the corresponding test, create some realization, we combine the two together, and then we show some more graphical analysis. At this stage, it is going to follow whatever one that is going to follow the same thing.
Okay, Doc, so the figure one I'm looking at, none of it seems to be the same. This one is having a sharp rise from 2 to 4. Yeah, but none of the graphs here have that.
No problem. So you have to highlight all of these other ones and continue.
Okay.
With all of this nonsense, but they're all important.
Okay.
And create. So when you look at some of them,
all these are under the leak test.
Can you imagine?
Wow.
So this is a final answer.
Okay.
And in the final answer, you can see the 7.613 and the p-value. Take a time, you see it in my console. You get it?
Look, it hasn't come yet. Okay, yes, like I'm seeing it, 7.62.
And you can confirm the p-value as well.
Yes, 0, 0. Okay.
And that's the same thing you also see in the lead test column, isn't it?
Yes.
So that's how to do that one. For the graph, I don't know why it's not showing. And I was like, yeah, no, brand new. Maybe we did a new graph. Now, let me see. So all of those things, follow that thing. That's why we didn't want to change the name and then rather maintain the data.
Yeah.
Okay, OL. Which one is the OL? Location. Location. Which graph is the one in the document?
Okay, says they have local and multinational for location, and then private and state for technical efficiency. And it's the kernel density plot of efficiencies.
Commands, I'm not also but like I said, I could not see this. So let me see. If I go through these commands, but that would mean that I need to run all again, not just yet.
Yes.
To run all again in MA. Okay, maybe I'm not doing the bias corrected now. Which one did I do? Let's see this. This is for D2. Let me just go up here and see. Oh. And then I made a cry. Now I need to look for the bias corrected. 1 second. So let me just highlight everything. I mean, yeah, everything. I mean. Scale efficiency is also there. Check it.
Okay.
Have you seen?
Yes.
Do you see the 7.4? Anyway, when you check, you see that one too is there. For the Wilcoxon 38,406 is also there.
Yes, 406, yes.
Now for the Lee, my own challenge, let's say. I'm trying to see why I'm not getting scale efficiency. And it looks like it's not there. Oh, that's a no, but I think we added color here. It doesn't look like it. Check this, check the one at the bottom right.
Okay. Is the sharp rise from 2 to 4? That's the difference. That's the difference. None of them have that.
Anyway, that reminds me that because this is bootstrapping, the thing about the bootstrapping is it changes. Because once you resample with the replacement, the scores will change from the previous one.
Okay.
Yes. So just so you know. But my only thing is that it should have still given us the colors.
Okay.
Unless maybe we did that command somewhere else. No.
Okay, yeah, this one seems more like the one on there.
Yeah, because it's doing bootstrapping, the scores will change.
Okay.
I even thought that this last one with diagram would have given us some very good diagrams. That's six. Oh, no. So check if the statistic is 11.34 in the document.
Doc for the mean or which one?
For the scale efficiency, lead test.
Lead test for scale efficiency, yeah, 11.35.
The p-value is 0. So
yes.
So all you got to do is to just do the changes up to the data sono. And once you replace the data with the name of your sono,
Okay.
The rest will now take care of itself. So maybe your data one will be for the DEA, your data two will be for the MEA.
MEA, okay.
What I need now is to get the right command for the right command for why the color of the graphs didn't come. Because that pattern in Chelsea. I don't get it, crap. Is actual paper. The same thing. Chelsea. The graph I'm in Chelsea.
Okay, Doc, please, then when you get a chance, you send me the new one.
Okay. Now the thing is that either is not there. It's either is not there. There's something called ragged. See, I've done this thing before, where if you look at grab the legend, the naming, and all of that.
Yes.
And then at the bottom, you see that those things are a bit of dot sort of thing. And in person message show. I either have it now or I don't, because the thing is that if you remember, I'll forget. There's a name for it. It's called rag something. It's called Kernel density with rag something. Okay, so let me see. KDE with rags, okay, in R, legend should be added as well. So let's look at one. Practical. So there's a kernel density. You see, this is a kernel density with rags, which is at the bottom there. My opinion. Okay. But we will need that. Other than that, we may have to use violin plot to showcase that. You see, this one too has got a ragged at the bottom. And then the group legends are also here. These are the commands used to generate all of that.
Okay.
Don't worry, you can do it on your own, can't you?
Yes, sir.
All right, so we can move on. So we will need the data, and then we will need to be able to establish all of these. Okay. Before we continue, do you have anything to show us?
Talk on the paper too, no.
Okay. Which means that you have something to show on another paper.
No, Doc, I was working on the measures you said for the AI one.
You're working on what? Measures?
Yeah, the AI, the variables.
What about it?
Yeah, that's the one I'm looking at the papers and then bringing out the variables they used. I'm putting it in an Excel sheet.
Okay. They are doing some induction, that's why I've turned it on. So that I can give you some tips from that.
Okay.
Actually, I'm not able to continue much if we don't have the data now.
The tables, okay.
That's why, but what I can sense is that looking at these works, we've spoken a lot about the work by Asma. You can see that I've been highlighting and underlining a lot of the PDF here.
Yes. Because
each point is important. Now, this guy, let's not forget, they were talking about only efficiency and not productivity. Okay. So, if you don't take it, go and write everything. Or you draw the point from everything. But I like it more when they talk about the thing and then they also discuss a bit of policy. So, for example, this one here, after they've talked about the whole thing, then they spoke about government can allocate extra capital and resources to environmental governance. Okay. That was a very good point. You just think about that statement. Government can allocate extra capital to environmental governance, emission control, and energy efficiency technology in this area to support sustainable development. And he was talking about the East. However, the Central and the West areas have low levels of economic development, less developed transportation and communication networks, poorer. So he was listing certain features of the North and of the West. Get a point? So when we come to realize that there is something that the West have more than the Eastern European, or something has more than the Eastern European, let's get some statistics to prove, say, Eastern Europe does well or better in something than Western Europe. Central Europe does well and better or bad in something than Southern Europe, something like that.
Okay. I'm going to use the search engine you put in the group to check.
Yeah, because that will help to be able to address the reason why one of them is lagging behind.
Okay.
And move along with the work. Read the work whenever you read what I'm typing there and bring ideas. Because sometimes when you put this work on your CV, people know that you didn't do it. And sometimes ask you some questions. Not you say that, but you said you wrote this paper. So whatever you are asked on the paper, it must be like you wrote it and so on. Other than that, yeah, chill. Yeah, chill. Oh boy. Okay. So the next thing was to now focus on the efficiency patterns. You see the patterns. So, but watch it. It says patterns of the regions. So talking about the patterns, we say copy asthma no more than the power. In country or copy or more papa. Anyway, this one, like I said, we will also have this thing for productivity across the regions over time.
Okay.
We'll have that, So for each region, how is productivity changing over time? You get it?
Yes.
And I'm kind of beginning to wonder whether we can even have productivity scores and do the kernel density. So once we are able to get to the kernel density analysis, we can use that for the productivity scores as well. Anyway, so he did these line graphs. Then he also did comparisons group by group. And again, it's the same using of the statistical testing. If you look at this table now, or check it whether it's significant between this and that.
Yes.
That's what he did. Then after that, in his case, he decided to focus on the energy. And the reason why I will not focus, the reason why we will focus also on the energy, all right, but not only energy, we will focus not on the efficiency part, we'll focus more on the productivity part. Like, how is the productivity of energy, how is it changing over time, and how is it changing across regions? Okay. How is labor changing over time? How is labor changing across regions? How is capital changing over time? How is it changing across regions? Was there another group we looked at? Only geolocation, huh?
Yes.
Okay. How is greenhouse gas emission changing over time, and how is it changing across regions? So those are the things that we are going to have the values basically for. Let me go back here. Also, he used that stack bar plot I'm talking about.
Yes.
So look at some of these things. He also used the area plot. Okay. But basically, we are left with the patterns. And to be able to get the patterns, we need to get that result.
Okay.
Maybe I need to also discuss with you for the productivity one, so that now the account properly, so that you know how to organize that one.
Okay.
So that it's not only efficiency. So once you finish the efficiency one, put it there, And by the way, I think you're mixing where the results should be. Sometimes I see the results in main data. Sometimes I see the results in articles. Sometimes I see the results somewhere. Need to check it so that I know exactly where they are.
Okay, so for the one with the efficiencies, I'll name a workbook efficiency and put those ones in there. So they'll have
Where?
7.
Where? You put it where?
Doc, under the main data.
Yeah, but why should it be in main data? Main data is under what? I thought they are all going to go into paper 2.
Okay.
I thought even whatever you have in main data is paper 2, isn't it?
Yes.
So everything about paper 2 should have gone into paper 2.
Okay.
Okay, easier. As a human piece, so once I open Emily thesis, I know that paper 2 is where everything is in there.
Okay.
So let me go to the productivity. And to do that productivity one, we need a few things. Activity, the stories in the so gotta be careful. So I decided that I'll go back to this guy's paper, and then see how he analyzes Leuenberger productivity, Marcus Leuenberger. You get it?
Yes.
So that is why I've highlighted several things for the discussion. So what was the first thing for the discussion? Okay, so let me show you. It says, based on the modified results, it is related VRS. We calculated the Marcus Leuenberger productivity of each year and its component. Then he listed the components from the year 1999 to 2012. So we will now have to refer to our models that based on our MEA specified in 5 and is related VRS specified in 7 and 8, we calculated a Marcus productivity in equations 13, 14, 15, 16, and the components, efficiency change, technological change, scale efficiency change. Get a point?
Yes, Doc.
From the year 2005 to 2022, something like that. Now, according to this guy, he indicated that the average, so the first thing to talk about is the average. The average annual productivity, and he explained what that means, is a geomean of all the 13 years indexes. That is the 13th root of the product of the growth rate from the 13 pairs of years, 1999 to 92, 2000. You get a point. See the way he's explaining nicely there.
Yes.
So normally this is a matter of editing yours to the taste. But watch something. So that 13 years, that overall, it is the one you normally calculated. It's not the year 2005 and 2022, dear. No.
Okay.
It's not the one to establish transitivity, no. But it's a geomean of all the scores. No. So if you have the productivity score for 99, 2000, 2000, 2001, 2001, 2002, you now take the geomean of all of those.
Okay.
That's what he is talking about. Now, so there are a few things we need to establish in our own. I think we did mention it. To what extent? So the first one,
That just sounds like
group.
They're doing a Zoom meeting. Like they're having the meeting right
now. And I mean, my free move. We free move, I pay the leader, they frame. They say, I don't blame them. So now sometimes, oh, you're not, will be catch us or join a presentation. All Casanon quad, you don't find your fear. What you say?
No.
So, oh, yeah, go back our presentation. Now, some go for joining us, my joining. But once on Casa will pay joining your whole boy. Participating, yes, it isn't a papa yaching or catcher me seven.
He knows that if you are there, you make yourself known. Hello?
Yeah.
Okay. Okay, then, Doc, why don't I use this opportunity to finish with these tables? Then maybe tonight, or if I finish early, we discuss them, then I move on to the productivity one rather.
All right, you're Martin.
Okay.
All right, thank you.
You're welcome.